And I guess we are live.
There we are.
Yep. So we'll just wait like 20 minutes. I will expand. If anyone, so we have 3 viewers. So I'm hoping whoever is viewing, and it's not one of us, because we do not actually have. Let me see if there's a way I can hide all my things. And I will definitely. This is really weird watching like what I'm doing and like because there's like there's a 3-second delay, so I'm just like don't worry, we'll edit all of this later. Post editing. Okay, so actually I'm going to change, I'm going to look at something, Gene, because I realized that you are slightly cut off.
Okay. Yeah, I was just looking to see if that was an iPad thing or an iPhone thing, or
No.
I guess not.
Nope. Yay. try one more thing.
It looks like it's coming through fine here.
Okay, that's good. Yeah. Just checking on. I'm just kind of looking at the monitoring from YouTube right now, and it still says it's good. I have a warning where it's not. It is complaining that it says that this may not be the most performant, but it didn't give me that warning before, so I don't know what's the difference, YouTube.
Okay.
But I guess like if you want to start in a minute, I'm trying to see how many people are. Right now, there's only 3 people in.
I'm showing 8 people on right now.
Oh, you are, okay. Then my thing's a little bit slow. So I was going to, hopefully if someone can hear us, if someone could post actually into the chat to see whether or not the sound sounds good for them. Because I think Gene and I are a little bit biased, because we can definitely hear each other.
Yeah, can anybody out there on live chat go ahead and let us know that you can hear us? No one's jumping in. Oh, Max can hear us. Thank you, Max.
Thank you. I hope Max is doing well.
All right. Well, then, do you want to go ahead and get started, Cynthia?
Sure. So thank you all so much, and thank you so for your patience as we have been trying to figure out how to give you live events. So this is our first YouTube live event. Hopefully everything goes smoothly. And then hopefully we'll have more of these as we're all trying to survive this wonderful pandemic. Trying to find the positive and whatever we can, the silver lining. So for those who are new to dcast, and this is your first event, welcome. We hope that you'll. We're really glad that you decided to come and join us and be a part of our community. Um, if you haven't done so, we do have a Slack. If you want to sign up for it, you can send us requests at dcast.io. We'll put more information on the live chat afterwards if you want to sign up. But with that, also some events that we're actually really excited for this lineup of performance testing that's coming up. I'm sure now with the current state of things, like performance and reliability are more important than ever for applications. So thank you very much to Gene for coming at the last minute to give us this presentation of performance testing, really an introduction to performance testing. Next, in the next couple weeks, we actually have another talk about actually like performance testing more extreme. So we have a few people from FINRA who are going to be presenting to us about how they have been using load testing to help them make sure that their systems can handle large amounts of load. So we're very excited for that talk that's upcoming. We'll be sure to have this all set up for you, so hopefully it'll be just as seamless. So, and with that, we're just going to hand it over to Gene to take it away. So, Gene, the floor is yours.
All right. Thank you very much, Cynthia. So welcome to dcast. Cynthia, obviously one of the organizers. I'm one of the organizers too. And we, as she said, we had wanted to do a performance testing talk tonight, and I had one available. So due to our moving the one at scale, the billions of transactions at scale talk to next week, we filled in with mine. So I hope this is what people want to hear about since it is performance testing. But this is called How Fast Is My App? Performance Testing 101. I work for a company. Well, my name is Gene Gotimer, and I work for a company called Coveros. We do development, agile and DevOps transformations. We do training. We do security, DevOps, DevSecOps. We have a couple open source products. One of which was largely designed and built by somebody in the audience here, Max Saperstone, who has just recently left us for greener pastures. We do work. I'm outside the DC area, like I'm sure many of the DCast members are. But so we do work for commercial clients. We do work for government clients. We're about 50-50. I happen to do a lot of federal government work. But anyway, enough about Coveros. Let's talk a little bit about performance testing. So hopefully this will come through. I want to start with just one quick little video here from one of my favorite shows, which will definitely show how old I am.
I would probably just be eating them. I'm going to try to wrap them.
All right. I'll let this play out a little bit more, but this to me is a great example of some of the problems we have when we talk about performance testing, partly because performance testing can mean so many different things, right? Am I going fast enough to get the job done? Can I keep up with demand? Am I going to miss anything, right? Do we need more resources? Do we just need to slow things down? Do I have to stop doing other things by the time we get to a certain speed? Can I just start cutting corners and make up for it later? Can I, what happens if it starts going faster, right? What if it's faster for just a few seconds? What if it's faster for an extended period of time? Can I catch up? Does it just start breaking down entirely, right? There's a lot that I love in that video, aside from the fact that I happen to love I Love Lucy. But let's start talking about the principles of performance testing and how we start answering those questions. All right. So the first thing is obviously people hate to wait, right? Anybody sees this cursor come up and sees that the page just isn't loading, right? They know something's wrong and their patience is fairly slim. So the first thing to talk about before we get into any of the principles of performance testing is really just talk about page loading, because that's a big one, right? Users are really, really selfish when it comes to page loading time. They don't care why. They don't care what problems you have on the back end, that you're under load or that you're understaffed or you don't have enough resources. They just want the page to load quickly. Okay. And very importantly, along with that, if they think it's too slow for them, it's too slow for them. It doesn't matter if you can prove to them that it's not, that you can prove to them that it's fast enough, that it's their internet or whatever. It doesn't matter, right? The page loading performance is always going to be from the user's point of view, and it's their opinion that's going to matter because, after all, they're going to be the customer when they're looking at web pages. So browsers often have performance measurement tools that we can use, and I'll show you a quick peek at a couple of them. But the big thing here, remember, if the users think it's too slow for them, it's too slow for them. It doesn't matter if we can prove that they're quote unquote wrong. So let's take a look at this. I have some pages here. I know it's kind of hard to see because the graphics are fairly big, but you can kind of get an idea of what are some of the pieces in here. And I'll zoom into a couple pieces. This is just an old page from the MLB.com site, and this is in Google Chrome. And with the developer tools turned on and looking at the network, you can see a lot of performance information. And there's some really neat things you can do with this. For one, I can look in at what they call this waterfall chart, where you can see as the page loaded, where did certain things start happening? What did it look like at different times during the load? How much could the person see? Were they able to actually start reading content, or was it still loading to the point where they couldn't make out anything comprehensible? As we get more and more complex websites, it becomes more and more important for us to look at this. So you can see this waterfall chart, and there's plenty of sites out there that will explain how these work. But see what was loading, what image was loading, what text was loading, what JavaScript or CSS files were loading at what given time. You can get screenshots along the way. You can see it's every couple of hundredths of a second they have a screenshot, so you can see what it looked like at that time. They even have some neat tools where you can actually see you can actually set the perceived speed, right? So I can pretend I'm on a slow 3G connection, which is probably too slow for any of us to tolerate these days. But I can see what's the experience like for someone on a slower connection, right? I might be on a great connection in my office, my home office, looking at great speeds, but for someone on a slower connection, is this not bearable? Is this not tolerable? I can also do this same type of thing in Firefox. Firefox has web developer tools that have something similar, right? You go to the performance, you can see let's zoom in here, you can actually see some of the different settings they have, different speeds you could pick. They actually have some charts that I don't 100% understand how to interpret all of it, but you can kind of see, based on an empty cache, what types of information had to be downloaded. There's another view that will show you if you're not on an empty cache, if you've already been to the page once, right? And it'll show you how all these things load, in real time, dynamically. What are the experiences? Where am I wasting my time downloading and all that?
Gene, I'm going to take a pause for you really quick. I think there was some interruption. Let me just reset really quick.
I think I'm looking good. I'm watching the stream here too.
Okay. Just waiting for, okay, Google's back to being green. Thank you, Gene.
Yep, just let me know when I can go again.
Okay, I think you're good.
Okay. All right. So these tools are really good, and they're really aimed towards people optimizing individual web pages, which might be something you need to do. But if you do, you already know far more about these than I do. But they're good tools to know that they're available and take a quick look at if you're dealing with a one-page app and things like that. One of the tools that I find more useful than the in-browser pieces, mostly because I work on the back end and I just like to run things through and get some feedback, is Google Page Speed Insights. It's just a website you can submit a URL to, and it will give you a score, and it tells you all sorts of information about how your page renders and what people are going to experience. So if you just scroll down on that particular site, you can actually see, when was the first contentful paint? When did the first screen come up that people could use? Or first meaningful. How much time until it was interactive? Right, almost 10 seconds. All sorts of different information, and these are all explained really well. This is largely based on a tool that Yahoo used to have, Why Slow, and there's lots of details out there. This becomes very easy to use because you just submit a URL to it. The downside, of course, is that you can't do something in your dev environment if it's not publicly available. So this might be hard to get to for some people. The in-browser options are great if you don't have this publicly available to somebody. So anyway, those are some good tools to start with, just to know about page speeds. The rest of the talk is not about page loading speeds, but it is really important to keep in mind that from a user point of view, that may be the most important thing that's happening to them, because that's the piece they deal with right off. So key takeaways here. If the user says the page is loading too slowly, it's loading too slowly. It doesn't matter how fast or that you can prove that that's not true, it's too slow. And so use browser and website tools to measure the page loading speeds. All right, so now back to principles of performance testing. All right, ISTQB actually lists these out, the actual principles, and these really come down to what are we measuring. So, how long does it take? That's time behavior, right? How big a system do we need? This is also part of performance testing. What are our resource requirements? That's resource utilization. How much can we handle at once, right? And that's measuring capacity. So all of these three pieces make up performance testing. And one of the keys is that when you are talking about performance testing, we need to be clear on what we're trying to do. What are we trying to find out? What are we trying to convey, or information are we trying to decipher, right? So let's go through a couple different types of performance testing. First off is load testing, right? Can the system handle increasing levels of realistic concurrent load? Whatever is being thrown at it on a normal day, day in, day out, can we handle it? Can we handle that load? That's load testing. Similar is stress testing, right? Can we handle peak loads at or beyond what we expect to handle, right? If all of a sudden we become really popular, someone mentions our website on the Today Show, what happens? Can we handle it? Can we scale up fast enough to deal with it? Scalability testing. How much scaling can we handle? Can we keep providing acceptable performance as the total number of users grows, as the concurrent number of users grow, as the amount of data grows, right? This might be something that happens over long periods of time, or it might be a spike that happens all of a sudden, right? And that leads us to spike testing. Can we handle a sudden peak load? Not our normal load, just all of a sudden everybody logs on all at once. Can we handle it? And can we make do with whatever type of service we can provide during that spike until everything calms down and we can catch our breaths again? There's endurance testing, right? Can I just keep this up forever? Can I sustain a stable performance over a long period? There's no memory leaks, no resource leaks. Things aren't going to die. I don't have to constantly take this down every night to restart something, right? Can we live for a long period of time? Concurrency testing, right? Maybe we can run fast, but we can only support a certain number of users at a given time. So what happens when a bunch of users log in at once, check out at once, do a search at once, do a mix of all the types of things? Can we keep everything going all at one time? And then there's capacity testing, right? What's the maximum number of transactions, the maximum number of users, the maximum number of data that we can have in our system and still provide acceptable performance, right? A lot of people have run into this when they're doing their initial development and they have 2 or 3 hundred users or pieces of data or items in their database while they're doing their testing. Everything looks great. They get out to the live site and they throw 200,000 catalog items in it and 20 users using it all at once, and all of a sudden it grinds to a halt, right? That's capacity testing, right? So the key takeaway from this piece, performance testing is a field, not a particular kind of test. So make sure you understand what you're trying to test for. Be clear on it. All right. What I'm going to do here, I'm going to do a little demo of a couple different tools, and I'm going to show you a Spring Boot app. Real simple. It's a static web page that makes some calls out to some REST services. It really is just showing a couple different types of sorting. And it's going to show some good sorts and some bad sorts. If you know anything about computer science, you may recognize these and what they call the O notation. But the site is out on, or the code is out on GitHub. You can download it from there. And all this does is use different sorting algorithms to sort 20,000 shuffled up words. And I use different types of sorts. Some of them are good sorts, some of them are bad sorts, with the idea of showing that, hey, you can see different types of performance and we can measure it with a couple different tools. The two tools I'm going to show today are Gatling and JMeter in particular. All right, and the tests are all in there, and again, you can grab that from GitHub. So first off, Gatling. Gatling's a load test tool. It's there's an open source version. There's also a commercial version, right, that you can pay for and get support for. The simulation scripts are written in Scala. That may be one downside if you don't already know Scala, but you don't need to know much, right? It actually shows they actually end up being fairly readable. You don't need to know a whole lot about the different about the language itself. You can figure it out because it includes a web recorder, and I'll show you that in just a second. That really will show you how to that you can actually just turn on and use as a proxy and run through your scenarios and whatever tests you want to do and capture the traffic, and then use some simple controls to scale that up and make some changes. So let me show you kind of what that looks like here. Let's go ahead and let's get off of this for now. Let me show you something better. I'm going to show you what I mean by code. This isn't great. I think it's a little bit small maybe, but this is what gets recorded. And I'm going to just look through a little snippet of it here. This is what Scala looks like if you're not familiar with it. I'm going to run through a simulation. It's called recorded simulation just by default. I'm going to hit a home page based on a particular URL, and that URL is on something running locally. I'm going to pretend I'm a Mozilla browser, and these are all the settings and the way it all works. It's all set up. This is all put in automatically for me, but you can go ahead and tweak it if you need. And then we're going to run through and hit a number of different URLs and pass some different values. And each one I'm going to run, I'm going to repeat this whole sequence 10 times. I'm going to take a pause of 1 second in between each of them. I'm going to hit a different page and capture the data from them, right? And I'm going to ramp it up as 2 users doing that over a 10-second period, ramping up. Okay, so I realize that's a lot I'm throwing at you. I'm going to go ahead and run this. Let me start by starting up the application. Oops, did I get the right one? Yeah, there we go. All right, I'm going to start up my app. It's already compiled. It's going to start up fairly quickly. I only use Spring Boot because I am familiar with Java, and this starts up its own web service and everything. I don't need to do much to do it. All right, and then I'm going to go ahead and I'm going to start Gatling. And Gatling, the recorder starts up. Actually, I can do it right through Maven with Gatling Recorder. That's going to go ahead and spin up, and I will get a page that I can bring over, or a screen I can bring over. And I know this is small, but that's what it looks like. I basically tell it where it's loading, where it's running, what packages I'm looking at, where I'm going to put this in, and it'll record everything for me as I do things. All I need to do is set this up to work as a proxy. That's what this HTTP proxy mode is, and I can run my tests through it. All right. So if I want to do that, I could do it through here. I can also just have the tests already written and then rerun them, right? So I've already recorded a test. That's the one you're seeing behind me, but that's what would be created here. And I can go ahead and just run that. So let me go ahead and close up this, terminate that one. And I'm going to go ahead and run this particular test, and we'll see it run through. Let's see how much we'll be able to see on this. All right, so it's starting some tests here. I know there's not much you can see, but there's also not much it's going to tell. It's just getting started, and we're going to start seeing the test run. And the test runs in about, I think, 2 minutes. So I'll talk through as you see it scrolling here. Right, it's doing 10 different tests for 2 different people running. So we should have both of them running here. Let's see if I can make this bigger. There we go. You can kind of see how it's running. It's running. These are all the different tests it's running. You can see how many times it's hit each of those pages, how many times got back good results. We're going to get to 10 on all of them. Active 2 is just talking about the 2 users running. And I just ran this, like I said, just there's a Maven plugin for this. Very easy to plug in. Most of the work is done by the recorder the first time. And like so many record and playback type tools, the easiest way I've found to use it is go ahead and do your basic recording the first time, and then you go ahead and customize the code, because it's generally pretty easy to figure out what needs to be changed and deal with the code from then on. And only when you need new tests or try to figure out how to do something special do you have to go in and actually do things with the recorder again. So I think we got to get to 20 on each of these because we have 2 users running. So while that's coming up, I am going to go ahead and pull up a window here, side, and load up the page. So one of the things I like about Gatling, this is almost done. One of the things I really like about Gatling is that it does a really good job of producing a nice, easily readable report. This is almost finished. I'm going to go in on my other screen here. I'm just going to pull this up. The results of the test. And where is that? There we go. Okay. It's all finished. It tells me right here, that's where the file is. And I can actually just grab this, grab that HTML file. Go ahead and plug that into a browser. I think it will come up. Yep, there we go. And I'll zoom in a little bit so we can see this a little bit better. This is the type of result it does. Now, we did a fairly easy test. We didn't break anything. There's nothing that died on us. We can see it got to each of these sites, each of these types of sorts 20 times. Again, if you know anything about sorting techniques, these might not be too surprising to you, but bubble sort is very slow. Insertion sort is slow, but not as slow as bubble sort. Things like quick sort, heap sort, merge sort are all different types of sorts that are fairly quick. And Java built in has a very fast sorting algorithm that does a little bit of hybrid of all of them and can dynamically adjust the way it runs, so it's a little bit faster. And you may have seen, I can actually click on some of these to see which is the fastest, which is the slowest. I can sort them either way, look at the data. If there were things that failed, I could see information about them. Talk about how the users, you can see how the users ramped up. It started out with 1 user, but then a few seconds in, we got a second user and they ran through. We got all OKs. We could see the distribution. Most of them came back quick, but we had some slower runs. These are going to be probably our insert sorts. And out here, we had some really slow runs. These are going to be our our bubble sorts. Kind of see the different types of sorting there if you wanted to sort through it. There are lots of different graphs and everything, but you could definitely play with this. A lot of information you can find out. I find that the chart, I like dealing with the numbers. I find that the chart's really the best piece. So if we were to match this up with true expectations, these would pretty much match up. I also have in here unsorted. This is just grabbing the list. That's my baseline. And we hit the home page so to start each of the tests, so it actually sees what it took to bring up that one page. The rest were hitting the REST services that I had attached to it. Okay, so one of the questions in chat there, does this work for 10,000 to 20,000 virtual users? So I mentioned there's a commercial version of this. One of the things about Gatling is that it runs, the free version is really set up to run from one node. There are ways to do it, but one of the advantages of the commercial Gatling is that it does give you ways to distribute the load. This is really a load generation tool. So the idea is, can it send as much data as you need in order to represent 10,000 or 20,000 virtual users? So it really depends on your hardware, but generally at numbers like that, we're talking about trying to distribute that from a number of different hosts. And in fact, you might want to do that from a number of different places around, not all hitting from, within your, excuse me, not hitting from within your local network to represent real world a little bit better. So can it do it? Yes. We're going to look at JMeter next, and JMeter has some other options that will make this a little bit easier. Okay. All right. So that's Gatling. Real brief, I realize, but let me go ahead and close this one up. We see Gatling had run there. We looked at Gatling already. Let's close that one up. Let's bring back up the presentation, see if there was anything I forgot to talk about. Gatling, we looked at the different sorts. Well, this case, since it's a live demo, in case you couldn't see anything, but yeah, there's the code, right? How it runs through. Get the results. All right, so that's Gatling. All right, let's talk about JMeter. Now, I like Gatling because it really does a really good job of generating those reports. It's very easy to set up. The Scala, even though I don't know Scala, it's very easy to read and easy for me to modify. JMeter is a little bit different. JMeter is far more popular. It's free and open source. It is also a load test tool. It's written in Java, but the tests are configured in XML or via GUI. So when they say JMeter, it's not for testing Java code necessarily. It can be, as it is in this case, but it doesn't have to be. JMeter, Java is just what JMeter is written in. One of the things about JMeter is it's written to test HTTP, HTTPS. It can test SOAP. It can test REST. It can test JDBC stuff. I'll tell you a little story towards the end of how we've used it in the past. It also includes a web recorder. Like I said, very, very popular. So let me go ahead and spin up this one real quick now. One of the things I have for that, it runs. I'll take a second to pull it up. I did not pull it up ahead of time. So it has a recorder that you can use as a proxy as well. Let me pull this over, and I'm going to go ahead and zoom in a couple times. It doesn't do a great job of it, but I can at least get a little bit bigger so that you can see a little bit of what it looks like. All right, and now I'm going to go ahead. I'm going to open up the code here and show you what it looks like in this UI, and I'll show you why I'm showing you this instead of the actual XML file that it generates. But yeah, it's the same type of setup here. In the UI here, we go ahead and we tell it to pull up the home page, right? In the home page, we're just going to hit port 8080 on localhost. It's just a get. We're going to pull up the unsorted list of words, same URL, right? With the /words. It's going to pass in a parameter here, and I can kind of walk through if I want to pass in the bubble sort parameter to that same URL. I can do that, right? And it can just look through each of these types of sorts, right? It's doing the same test essentially that we did on the Gatling. I put it into a thread group which tells it I want 2 users to ramp up 10 seconds and run this test 10 times. So almost exactly the same setup as before. And at the end, I want to generate a report. Okay, so that's what it would look like using the tool. Again, you can set it up as a proxy and have it record for you. But looking at what the code looks like is a little bit different in this case. In our code here, which one is it? That's not what I wanted to do. This, what JMeter looks like, JMeter code looks like. It is a huge XML file. It is basically every setting on every screen that I go through in the GUI. So it is far harder to write and modify things from scratch using JMeter. Okay, that's one of the really nice things. Like I said, even though I don't know Scala, that's one of the really nice things about Gatling is that I can actually look at the code and use it fairly easily. But JMeter has some significant advantages in some situations. So code's not as readable, but you don't generally deal with the code you generate. You generally deal with the UI, those same settings here, right? Which is actually fairly easy to do, and the UI is fairly easy to use once you get used to it. All right, but once the test is written, again, we can just run it. So I'm just going to go ahead and run my JMeter. We'll watch those tests run. Doing essentially the same type of test. We'll go ahead and start pulling that up. We'll hit the site that we have running. Go ahead. And here it's going to go ahead and kick off. And we're going to see it shows us periodic. It doesn't do a run after run thing. It just shows us kind of as it's going through. A little bit less verbose here. I'm sure we could get more details if we really wanted to. Let's let this one finish up. And we'll take a look at the results it shows. Should be getting towards the end. This one is a little bit quicker. All right. These tests are going to wrap up. It's going to tell us when it's done. And what it's doing, like I said, it's running through each of these types of tests 10 times for 2 users. Whole test takes a little under 2 minutes on this, on my particular computer. So that should be just about it. Come on. And as soon as it finishes up, I'll go ahead and I'll pull up that report as well. There it goes. It's done. The completed test. I completed this test. I can go ahead in my look at the report it generates. Let me pull up the right result here. I'll pull this one up over here. Come on. Did I do that right? Where is it? There it is. Okay. This is the JMeter report. Not quite the same look and feel, but it has the same types of capabilities as the Gatling report. This is one of the things that JMeter has gotten really good at over time. They do something called AppDex, which is a performance index. It'll tell you which ones you can measure, basically which ones are going to be people are going to tolerant of, which ones people are going to be frustrated at, half a second or a second and a half. And we have the same type of statistics here, right? Set up just a little bit differently, but I can go ahead and sort it by the max, slowest to fastest. We see the same type of layout as we did before. Notice that some of the results were small enough, like the unsorted was a little bit quicker in JMeter. So you're not going to be able to compare these apples to apples, maybe. There might be slight differences running JMeter versus Gatling. But as long as you stay within using the same tool, you'll have relative results that it'll show you. And most of this just has to do with the overhead of running and Scala and Java and what the framework has to do and what my machine was doing at the same time and all of that. So, so back to Robert's question earlier, could this handle 10,000, 20,000? Well, JMeter is completely free, so you definitely can do you can do it with JMeter, spread it out over different nodes. It's also not always trivial to do. However, JMeter is popular enough that there's quite an ecosystem around it, and there are sites out there like Lodestorm, BlazeMeter, and so many others that will actually take a JMeter test file, right? The JMX file that I showed you, the XML file, and they can take that and they can run the test on your behalf for a fee, of course, where they can run it with all different numbers of users that you probably could not or at least would not want to generate on your own. Plus things like Lodestorm and BlazeMeter, I think you can do it on BlazeMeter, but I know on Lodestorm you can tell it I want users coming from all over the U.S. I want users coming from all over the world. I want this percentage on a fast network, this on a slow network, and actually they'll just run it from cloud resources all over the place to give you some really realistic types of profiles for what users are going to experience, right? So basically, for a fee, these tools definitely can support large numbers of users, which would be really important. We're just looking here at some page response times, but if you were trying to do stress testing, right? Where does this fall over? Where do we break it? How much load can we handle before this fails over? As well as things like scalability testing, which we already talked about, right? If I want to do scalability testing, one of the things I have to do is force my failover to, or not failover, force my systems to have to scale. What happens? How fast is our system set up to automatically roll over and start up another server to run with us if we have automatic scaling and stuff like that in the cloud? How fast does that become responsive? Do we need to have it anticipate a little bit more or be a little bit more conservative in how we do it? All sorts of things like that, and that becomes really important for these load generation tools. Now, one thing I will mention, maybe I should have mentioned earlier, but I mentioned both of these tools are load generation tools. We consider them as performance testing tools in a lot of cases, but the reality is they're not actually testing performance. There's some tools around them that will. What they're really doing, though, for us is generating the load. And the types of code, types of results we look at, which are these charts we see, how we interpret the results, what types of, where we're looking for errors, how we design the tests even, are all really what's telling us what type of testing we're doing. So these tools are there to give us the data that we need to collect, and then it's up to us to design the test and interpret the results. So anyway, so that's JMeter. Like I said, much more popular than Gatling. The files aren't as easy to read. You're almost always going to use the proxy for JMeter, but neither of them are tough to set up. And both of them have some good ecosystems around them. There are plenty of other tools out there as well. These are just two that I've used in the past. If you don't know any better and you think you might have to scale or you might have to bring on new people, JMeter is your best bet because it's the more popular of them. People are more likely to have some experience and there's more help out there on the internet. If it's just something that's probably going to stay in-house and you're going to use it yourself, there's some good reasons to use Gatling. All right. Let me go ahead and get out of this. Close this down. Let's go back and talk a little bit more about the tools. All right. I showed you what the UI looked like. We ran the tests. Showed you that the XML file it generates is pretty much unintelligible, but generates in the end same type of report, all with a single Maven command. So both of those I ran them from my IDE just because it's convenient to click on, but they both would run really just running a Maven plugin. So back to the types of performance testing. We talked about all of these, and I alluded to some of this, but you can see we're using load generation tools so that we can do load testing, right? How much load can I handle? Stress testing. Where does this break? How fast can I throw stuff at it? Or how many things can I throw at it at once before it falls over, right? Where does it break? Scalability testing. Where do I need to scale up, and do I scale up fast enough? Like, can I add another server and another server and another server? Or do I at some point get database bound and scalability, ends? We have to start slowing other things down. Spike testing, right? If I'm humming along, one of the things I didn't show you, but there's certainly, you can kind of guess that the UIs have abilities to do this, but I could start with, say, 2 users hitting the site on a normal basis, just at a pretty steady pace. And then over the period of 2 or 3 minutes, I could scale that up to 1,000 users. And then 5 minutes after that, scale it back down to the two users or 10 users or 100 users or whatever we think our normal load is. And that's how you would do spike testing. Endurance testing. I had these set to run for 10 rounds. You can set them for times. You could just turn them on and let them run over a weekend, and just see, can it support that load? Does it fall over? Start monitoring the memory of the application that I'm hitting, and does it start leaking memory or resources or file handles, or is the disk starting to fill up because of logging, whatever, right? That's the type of things you do in endurance testing. Concurrency testing, right? I was doing 2 users at once on this. How many users can I throw at it and still handle? Can it deal with 10,000 users all at once? Can it only deal with 1,000 users all at once? Are there different parts of the app that it can handle, right? Maybe I can have 10,000 users browsing my e-commerce site, but I can only have 100 users checking out at once, right? It's just too much load. So a different section might have waiting rooms or something like that. And capacity testing, right? What's the total number of users we can have in there? How much data can we have in there? Is there a point where, hey, we need to start looking at different architectures? So how do we go about doing that testing? Well, we like to look at a testing pyramid, right? And generally with the testing pyramid, the tests that you have the most of, that you run the most often, they're at the bottom. Those are your unit tests. In the middle, we get up to functional testing. And towards the top, we have a fewer number, but maybe equally important, end-to-end tests that run, right, towards the top, right? There's fewer of them. We don't run them as often, because they tell us different things. So if I was to look at a testing pyramid for performance, I might start with unit tests, and we'll talk about those in just a second. Do isolated load tests, right? Just, hey, really quick load tests on little pieces of functionality just to see how they're performing and start looking at some trends, right? And that would be the next step. Get a baseline and get some trends of maybe a selection of functional tests, okay? Then maybe I move up through the API and start looking at load testing via the API. Then maybe I start looking at the UI, right? Maybe I have some JavaScript and some on-screen functionality that might slow things down or change the pace of things or handle things in a different way. So I want to do some load testing there. So as I'm going up here, I'm going to have fewer and fewer of these tests maybe. They're going to happen further and further down the pipeline as I'm building it out. It's not to say that they're less important, just that they provide me feedback at a slower rate. So I might want to push them later in my pipeline so I can get fast feedback all the way through. Eventually, I'm going to start doing some of that user performance testing, concurrency testing, stress testing, spike testing, right? I might want to do that right before we go live. It's the piece that's the hardest. I need most of the infrastructure up and running, most of the code ready before I can do that. And then finally, right before we go live, maybe right at the end of the pipeline, our final test is going to be full-blown transaction via the UI, endurance testing, capacity testing rather, scalability testing. We do all those because they're harder to do and they take a little bit more time. All of these are important. We want to get as much towards the bottom here of this unit testing that will give us fast feedback, so that we're not surprised when we do these tests. And that's going to give us confidence that these tests are going to run pretty well and we're not going to run into failures right away and we've wasted a lot of time. By the time we run these full-blown transaction numbers that we're going to report out to executive leadership, How much can we really support? What do we expect? These business people are going to make their decisions based on it. We know these tests are going to work. We're just collecting numbers, right? We should have really high confidence by having built up this performance testing. All right. Couple last things here, and then we'll wrap it up. I mentioned unit testing, and unit testing typically is not something that we would do. We associate with performance testing, but as a developer, I love unit tests and I rely on them a lot. One of the reasons they show up at the bottom of the test pyramid is because they give really, really quick feedback. So using another tool here, this one is actually JPerf Unit, just a Java test, or actually this might be right in JUnit, actually, I think is what I decided when I finally wrote this. I can go ahead and run some very simple isolated unit tests on little pieces of code. And the way to do this is to just write these tests. I'm just using some JUnit. This is JUnit 5, I guess, is what I did. JUnit 5 tests that just look at how many times I'm going to repeat a test, a timeout warning. So if this bubble sort takes more than 6 seconds, this is in milliseconds, I want it to fail. So I'm going to run it 10 times, make sure everyone comes in under 6 seconds. And I'm going to run it 10 times with the insertion sort, make sure it comes under 1 second, and run it 10 times on a merge sort and make sure it comes under 50 milliseconds, right? And I'm going to get some baseline, and other things might be happening on my machine or the machine that this is running on. So I do want to let some variance. I'm going to put some kind of hard stops. I say here, for instance, if the bubble sort usually takes 4.5 seconds, I may not want to fail it at 4.5. I want to fail it at like 5 seconds or 6 seconds, right? I want a kind of a runaway break. These are actually hitting code. This is not making an HTTP call. It's actually a unit test. I am running the code underneath to get some instant feedback. And this is a really great thing that developers can do to help the testers with the performance testing, is get a baseline of the code. So this is not going to matter on my network. It's not going to do number of users concurrently hitting it. This is really just running the code at best case with no network latency, no other load on the system. What am I going to see that code run at, right? This is no overhead from Apache or Nginx. It's just running the business code itself. The neat thing about this is it gives me a baseline that I can just monitor trends over time. And then if I make a change to the way one of these business services works, change the way I've implemented the merge sort, let's say, and all of a sudden it gets really slow, well, I know right away before we roll it out and we start doing some actual tests, before we even do a deploy. One of the ways, well, actually, I'm going to show you that in just a second. So I'll talk about how we've used that. So key takeaway here, remember the testing pyramid. We're going to use a mix of isolated end-to-end and end-to-end tests and everything in between to build up our confidence. All right, so let's talk about how I use some of this trending and some of the things I've mentioned before. Trends are really, really useful. It's not just about absolute numbers, although in your particular environment, absolute numbers might be really important to the business. You might have to collect them. But let's say we were doing a full load and performance test, right? We might do it on a dedicated environment with no other traffic. We've isolated the network so we don't have any, as little variance as we could. We have production size servers because we want to actually get our real numbers. Let's say it's 1,000 concurrent users for an hour. What's our sustained capacity and throughput, right? Can we handle that, right? But what we might want to do earlier in the pipeline is do a short JMeter or Gatling or whatever test, right, on a development system, no isolation, 10 concurrent users for 10 minutes, right, and track the trend. Are we getting faster or slower? It doesn't really matter what the numbers are, as long as I capture it once and say, okay, that's fast enough for me. Then the next time before I do a release, if I just keep running that same test over and over, every time I do a build, 10 minutes after I've done the initial build, I have some results that say, hey, things are still about as fast as they were last time, or maybe I've done some optimization and I find out that things are getting faster, which is what I want. I get some fast feedback on that. And one of the ways we use this in the real world in the past, um, we were implementing, for those of you that are familiar with the STIG, the Secure Technical Implementation Guidelines, a lot of government agencies, especially DoD, is required to have their systems meet. We were doing some stigging of a database system, or database heavy system. It was commercial software, but we were tuning the database to add some audit logging. And we wrote the log, we made the logging configuration changes, and we started running some tests, and it seemed a little bit sluggish, right? We didn't have any data, but we said, this feels slower to me with all that extra logging. Let's actually see what it is. So what we actually did, we backed out our configuration changes on the database. We're back to just plain vanilla logs that we had before. We used a program called PG Badger, which is a log analysis tool. We actually we were using Postgres as the database. So we looked at our Postgres logs, fed it to PG Badger, and it told us that here's how many queries that are very, very similar, the same query being run over and over. And it turned out that 85% of our traffic, or some number like that, four queries represented 85% of our traffic. So we just said, you know what, let's write 4 JDBC tests in JMeter. I showed you the HTTP tests, but we could do 4 JDBC tests in JMeter. They match those queries. We looped them. I think one of the queries represented over 50% of the traffic. One was 15% of the traffic. The other two were about 10%, something like that. So in the same proportion, we wrote these tests and built up a 10-minute or 15-minute test suite that just ran these tests. And just every time we did a build, after we gave feedback to the developers that the build was done, we kicked off we were using Jenkins at the time, kicked off another Jenkins job that just ran these tests using JMeter and created a baseline, right? So we had backed out our changes, ran these, and then we started watching the trends. So we went ahead and put the database configuration changes back in, reran the tests, and sure enough, we were slower. We were actually about 15 to 20% slower, so it was noticeable. So we went ahead and did some tuning and got it back to what we considered acceptable performance tests, but it was so easy to do that we just left those tests in. So from then on, every time we did a build, we had performance testing that we could look at to make sure we hadn't significantly slowed things down. This came in handy anytime we did upgrades or changed tools or changed components we were using, or like I said, just changed configuration to see if things were slowing down or speeding up in accordance with what we expected. In this case, it was database changes, so we were actually testing database changes for the performance impacts. But we also liked it so much, we stuck with JMeter and also added another 10 minutes of testing for our website and did some similar types of things. Ran it through an analysis tool, figured out, that I think it was 6 or 7 different pages that were being hit were represented some huge bulk of the traffic. We went ahead and set up the JMeter test to do HTTP testing in roughly that same type of proportion, created a baseline, and then we could just always watch it. And we saw the trends going, and if any time, we didn't even look at the absolute numbers, but if any time we noticed that the graph that was just shown in Jenkins going way up or way down, we knew something was going on, right? And we could look at it and see if it was something we expected. Okay, so key takeaway here, we want to shift performance testing left, get a baseline as early as possible, and you may be able to deal with just trends, right? You may not need absolute performance numbers. Trends may actually be just as actionable or more actionable. You can make decisions based on it and adjust your code and all of that. All right, last piece here. Testing is not enough. Don't let your performance be optional. Break things if you don't pass the metrics that you want. As soon as you start putting all this testing in, the unit testing, the JMeter, or Gatling, the performance, the JDBC stuff I was talking about, any of the stuff you put in, if you don't enforce based on it, it's going to be ignored. So you can be lax on it. It doesn't need to say, hey, if it gets 2% slower, we're going to start failing tests until it gets fixed, or builds until it gets fixed. Maybe you'd be a little bit more generous. I think the rule of thumb is that most users can detect about a 10% change. If you make a 5% change, if things get 5% slower, and then a couple of weeks later, months later, releases later, whatever it is, it gets 5% lower again, they tend not to notice it. They get used to it. But if it all of a sudden changes 10%, people do. So maybe that's a good rule of thumb, right? Pick a performance metric that says, hey, if things get 10% slower, I am failing everything. We're considering that not we're considering that a failed build, and we're going to use that non-functional testing of performance to go back and fix things. Because if you don't enforce the gate, people will just go right around it. All right, so break the build if you know something's too slow. Okay, we're at the home stretch here. Last couple things. One of the things we do at Coveros anytime we speak or do a presentation, we try to come up with the 5 key takeaways. We call it the Coveros 5. So here are my 5 takeaways that I see from this presentation. First, remember that if the user says the page is loading too slowly for them, it's loading too slowly for them, no matter how fast it is, right? It has to be the speed that it has to meet their expectations. Remember that performance testing is a field, not a particular kind of test. You have to understand what you're trying to test for. Remember the testing pyramid, you're going to use a mix of different types of tests. Don't put all your eggs in one basket. Don't rely solely on JMeter functional tests without doing any end-to-end performance tests. Don't do all end-to-end performance tests. You just get the feedback too late. You want to use a mix. And trends may be easier to test for and just as actionable as absolute performance numbers. If they're easier to get and you can react to them quicker, then they provide you more value. And lastly, and perhaps most importantly, you have to break your build if you know it's too slow, right? If you know things are not going well, you can't just let it ride. You can't just say, hey, it's just performance. We'll fix it next time. Because once you start doing this, it's a slippery slope. And for then on, you start running into more and more and more problems. All right. That's all I've got. Thank you very much. I don't see any questions in there. I do see a comment that perhaps Stigs are not Robert's favorite, which I would wholeheartedly agree with. Stigs are tough to deal with. For those of you that are not familiar with Stigs, they're a series of best practices or recommended practices. If you have a database installed, you should have these settings on it. If you don't need these pieces of the database exposed, set them up this way, right? And they have it for databases, they have it for web servers, they have it for OSs, all different levels. It's impossible, literally impossible, not just infeasible to address every STIG item. What you try to do is pick the STIG items that apply to you and fix those, and then explain why those were the important pieces to deal with. So, all right. Well, we have the dcast Slack channel, as Cynthia mentioned earlier. So if you guys think of any questions later on, I'll see them in there, and I can certainly try to answer them. If you have any really hard testing questions, ask Max, because he's far better at testing than I am. He's actually a tester, not a developer like I am. Yeah, and I will post the slides, and this recording I think will be on YouTube, but I do have the slides posted, and I'll post the URL actually to the GitHub repo if you guys want to download the code and look through the instructions in there with it. All right. Anything else, Cynthia?
No, actually, I did have a question for you, which was like, do you have any recommendations of how to view the performance test results in like an aggregated form? Because I think it's really great that you showcase like the different levels of which you can do performance testing, and trying to get that big picture. Like, do you have any recommendations of like tools or like frameworks that you like to help aggregate metrics from different sources into a cohesive view?
Yeah. So I mean, I only really briefly looked at the reports that it's generated, and I did not do any tuning on those reports. And they're very customizable, and you can get more types of graphs and data that you could use that would be really useful if we were doing something much more real life. Also, if you're using a service like Lodestorm or BlazeMeter, they have a lot of tools that will aggregate a lot of different types of tests and drill downs and stuff for it that make it I guess, more usable if you're using a real app instead of an example app that was really simple. But the other thing that I really do tend to do a lot of is just looking at trends and not worrying too much about individual things until I see a problem, right? If I'm doing even big changes throughout the architecture of my application, a lot of times what we'll see is some pieces will get a little bit faster, some pieces will get a little bit slower. Maybe I'll make some optimizations in some code that runs very, very frequently, and I'll make things a little bit slower for things that don't happen as frequently. For those of you that have ever done heavy database work, a lot of times if it's a database that you read from a lot, you'll optimize all the read queries, knowing that the writes might be a little bit slower because of indexing and stuff, but knowing that they just don't happen as often, right? And it's the same type of thing with your apps. But if I'm just looking at the overall trends and using that as my litmus test for how's performance going in general, I can get some really fast feedback and just keep an eye on it. And just, hey, as long as it's staying roughly equal and it's just hovering around a certain point, I know I'm good. And then I don't have to start looking at numbers and start looking at the details. If you do need to look at the details, say we're doing the end-to-end testing, we're trying to get real transaction numbers to tell the business how many people we can let in at once. Then you have to look at tuning some of the JMeter or Gatling reports, or look at the raw data it gives you, and then start doing some statistical analysis on them to find the actual data that you need if they can't do it. But I will say that JMeter in particular, there are tons of different types of reports that can be generated, and there should give you pretty much all the flexibility you need. To answer your question?
Yes, no, I think that's really great. I think we'll see if anyone else has any questions. Don't see any on the chat. I don't know, we should give them a couple minutes.
Yep.
Or not.
We'll let it sit for just a second, and then, like I said, we'll post the site, the GitHub site. This is GitHub is Covera sorting. I'll post that, like I said, but it does have. I'll update the speaker deck slides, but it also does explain how to run the app, where the code is for Gatling, how to run the UI and the tests, where the report is listed. Same thing again for JMeter, so you can get started, as well as where the unit tests are that actually measure performance. So you have some worked examples here that you can get to. All right. I don't see anything else coming up. So like I said, if you have any more questions for me, you can go ahead and ask them in the dcast chat, or dcast Slack rather, and I'll find them in there. Thank you all for coming.
Thank you so much, James, for presenting. As I'm not sure if I mentioned this before, but we are always looking for new presenters and people who want to share topics. So if you are interested in presenting, please let us know. We'll be happy to support you in any way. But thank you all so much for attending our first YouTube live event. We'll definitely do some adjustments for the next time. But thank you so much. I think this actually went very well for our first time. But
For our first time, yeah, I'm happy. I think we got through it. All right. Thanks a lot, everyone.